Hi guys, welcome back to the channel. My name is Ken, and today I am going to run through some tips and tricks on how to get perfect soldering every single time. So let's go to the bench and see what I do to achieve reliable soldering on my flight controllers, ESCs and my drones. This will apply to anything, any electrical soldering that uses solder and a soldering iron. So, you know, it's not just for drones, but in my case, I'm going to exemplify with some drone parts. So let's go to the bench. On the bench, I have my trusty little TS100 soldering iron, which is heated up to 400 degrees. I always keep it at that temperature. Some people like to change the temperature of the soldering iron, make it colder for smaller joints or bigger for larger joints. I prefer to keep it always at 400 degrees and use time. I vary the amount of time I leave it on the pad depending on what I need to do. So for a small little pad, I will just go in there really quickly, boom, and get it done. For a bigger pad, I'll leave it a little bit longer. That way I don't have to worry about temperatures and all that stuff. I also have some 60-40 solder, which is lead tin, so 60% lead, 40% tin. This is the preferred brand at the moment, Silverline in the UK. It's just a good quality 60-40 solder that I know is clean and free from contaminants. This is resin core. I also have some flux, which I don't use very often. I only use it for reworking, or if I'm doing some surface mount stuff and I need to encapsulate the whole area for a long amount of time so that oxygen doesn't get in. The main reason for the resin core and the flux is to remove oxygen from the equation. Oxygen is the enemy of any soldering or welding application. So even those hardcore stick welders have, you know, that core. I don't know if you've seen a stick welding stick. The sticks are encapsulated with a oxygen deprivation substance that when it heats up and arcs, removes the oxygen from the joint. You know, when you're doing MIG and TIG welding, they will use argon and CO2 gas and, you know, mainly inert gases to remove oxygen from the area, and that's what flux does. Resin core and flux just remove the oxygen from the joint. On the topic of oxygen, one of the important things you have to do is keep your tip clean. So I use this copper fluffy shreddy stuff. You can also use a natural sponge with dipped in distilled water to clean your tip, and there are also tip tinning compounds and different acids to rejuvenate your tip and to clean your tip. I find with this copper stuff you don't need any of the other bits and pieces. All you need to do is, when your tip is dull like this, all you have to do is dip it a few times into this copper stuff and you'll see it is now nice and shiny because it's removed all the oxidation from that area. Then you can tin your tip, you know, and you'll see that the solder sticks to the tip and creates a little droplet of solder on the end of the tip. That is ideal. Once it sits there for a few seconds, it will get dirty and oxidated again because of the heat. It attracts all the oxygen. Just dip it again and remove all that excess dirt and old solder. So onto the board. We have a couple of pads here. I want to put a thick wire on this positive pad here, and I already have a wire on this end, but I'll remove it and demonstrate how to attach that again and what we do to attach wires to this board. The most important thing you need to do is tin your wire. So I'm going to strip a little bit here of the end of this wire. You only should strip what you need. Like this is too much already. It might just be 3 or 4 millimeters, but that is way too much. I don't need that much. So what I'm going to do is I'm going to trim it down only to the amount that I need. So I just need 2 millimeters exposed there. Make sure it is twisted so it's not all hairy and that individual filaments of wire don't go everywhere and potentially cause short circuits. And then what you want to do is you want to tin the wire. To tin the wire, you just grab your soldering iron, a little bit of fresh solder on the soldering iron, touch it to the wire, and it'll be tinned. Not a lot, it's just enough. It's just coated the wire with some fresh solder. And what you want to do is tin the pad that you're going to attach your wire to. So in this case, let's put it on the ground pad. It doesn't really matter, it's just demonstration. So heat the pad up, touch the tip of the soldering iron with the solder, let it flow onto the pad. Just a little bit. Let's do that again. Touch the pad, fresh solder on the tip of the iron. It will naturally flow into place once it needs it. Let's do another one. There's 3, 4, 5. So, you know, within a few seconds, I've managed to, for example, short circuit this one. Okay, let's fix that. Quickly drag your soldering iron across the pad, and that will automatically cause the solder to stick to the iron and move away from the pad. I'll show you more on that later. So now we have a nice little tinned piece of wire. We've got some nice fresh solder on the pad that we want to solder it to. All we need to do is position your item comfortably. You don't want to be twisted over what you're soldering. So if you're coming in with the wire in this way and the soldering iron in this way, position your item accordingly so you can get in and touch and be comfortable, you know. So there you go. Clean the tip, touch the wire, put the heat onto it until the solder that's on the pad melts. Take away the soldering iron, and boom, there's your wire done. You can use a pair of tweezers if you're not, you know, if you don't want to burn yourself, or if you're not confident, use a pair of tweezers. One tip to not shake is to keep your hands, not shake, look at the camera shaking. Anyway, steady your hands. Be comfortable. If you're holding it in the air like this, if you're holding your hands in the air and you're trying to position the wire, it's going to shake everywhere. Lock your hands down on the surface, somewhere close by where you can use it like a lever to go in there, and you will not tremble your way in. The shorter the distance between your fingers and the tip of the iron, the less trembling will go on. So that's why, you know, just like when you're taking photographs, if you have your arms out, your camera's going to shake. If you tuck your arms into your body and take the picture like this, close to your body, it'll have less shake. It's the same principle. So let's remove this, and now move on to this big pad. So the bigger pad is going to need some more heat. With these boards, the negative pad pretty much goes all the way through the board. So that's the ground plane of the board. So there's about 2, maybe 3 ounces of copper in that ground trace, because it needs to, you know, it's got a lot of surface, a lot of current going through here. So you need more heat. You need to heat up the whole board before your pad is going to be hot enough to accept the solder. So I'm going to grab this wire. This wire is relatively thick. I'm going to cut this little pre-tinned bit off that I'd done earlier with my trusty toenail clippers. Strip off just a little bit than what we need. I'll use my nails for that, that's fine. Twist the little filaments enough, just gently, so that you don't get too many oils from your fingers on there. Then we're going to tin this wire. Just enough for the solder to be on the stripped edge. If you leave your soldering iron in there too long and start adding too much solder, what is going to happen is it's going to wick through into the wire underneath this insulation, and that will cause heat to dissipate away very, very quickly, and will cause you trouble soldering on. So all you need to do is just tip the edge, have enough solder in there so that it just flows into the edge, to the stripped off bit. So clean the tip, add some solder, at the same time add the wire, and just gently move it across until just the little tip bit has a bit of excess solder on it, enough for you to solder it in place. Then what you're going to do is we're going to tin the pad we need with fresh solder. This one has already been used, but we're going to tin it again. So add some fresh solder, very important, keep that oxygen away. Add enough fresh solder so that when you add your wire, the excess solder that's on the wire and the excess solder that's on the board will fuse together and flow together. So then we just touch our wire on top, clean the tip again, add some heat to the wire, let it dissipate through to the solder on the pad, and once you see it all flowing, all melting into liquid, in one go, you can remove the heat and you'll have a perfect solder joint there. That's very important. If you don't let the surface you're soldering to heat up enough, you will get what is called a cold joint. So it will appear to have stuck, but a little bit of pressure, if you tug on it or whatever, it will just break apart because the solder hasn't flowed together. It hasn't liquefied and soldered these two, welded everything together uniformly. So it's very important to have enough heat to actually make it flow, and then the solder will just flow like water. And you know, you'll have a perfect little solder joint. There you go. You can see there's a little bit less solder than I would like, but that is solid enough and reliable enough. I know that's not going to go anywhere. Okay, so the last little tip I have for you is how to remove solder from excess solder from the board. Like for example, this pad here has old solder. You don't want to solder back onto old solder. You always want to rejuvenate the solder. And if I just add more solder in there, it'll be too much and it might flow and cause a short circuit and just go everywhere. So we want to remove the old solder. I'm going to show you how to do that. There's 3 ways to do it. First way is to use a solder sucker. I don't have one. Second way is to use solder wick, which is basically some braided copper wire that you just touch onto the pad, add heat, and it will saturate and suck all the solder into this braided wire. I don't have any of that and I don't use it. The third way is to use physics. So the way I do it is you clean the solder, you clean your tip, make sure there's no solder on the tip. Just touch it onto the solder you want to remove, let it melt, and then quickly move your soldering iron away. Boom. Some of the excess solder will naturally gravitate towards the tip and stick to the tip and come off with the tip. Just rinse and repeat. Clean your tip, go back on the pad you want to remove solder from, quickly swipe away. Rinse and repeat. And you'll see after 3 passes or so, all of that excess solder is gone, and you can add fresh solder onto there to proceed with your next soldering, next wire. So in this case, look, I'm going to do all these pads at once, remove solder from all of them. Boom, 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 boom. Don't worry about short circuits because the actual fluid dynamics will prevent short circuits from happening. Once the excess solder is removed, all of those short circuits will just naturally clear themselves. So it's you know, once you get the experience, it becomes pretty straightforward. Once you learn how all of the materials and how all of the stuff works together, it becomes very, very easy. So those are my tips and tricks. I hope this is useful for you in the future. Let me know down in the comments if there's anything that I've missed. If you do anything differently, I would like to know. If I've made a horrible mistake, you know, call me names. I don't mind. That's how we learn. Stay tuned for the next video, which will come very, very shortly. Appreciate your visit. Thank you very much, and I will see you next time.